So, okay class, to continue, let's have the solution for this problem. Okay. So, for A, we are to solve for the horizontal, vertical, and inclined distances. By the way, you'll have the formula for first HD is equal to KS cosine squared of alpha plus C cosine of alpha. Okay, we substitute the values. You have your K, which is 99.5. And then S, that is A minus B, which is 3.5 minus 1. And then cosine squared of alpha, which is 23 degrees 34 minutes. Disregard the negative sign. Negative sign meaning that is angle of depression. And then plus C cosine alpha, but your C here is 0, so therefore this is 0. So you have your HD equal to 99.5 times 3.5 minus 1, so 2.5 times cosine 23 degrees 34 minutes squared. That is 208.99 okay, meters. That is the answer for horizontal distance. And then B, vertical distance. Formula is you have K times S times cosine of alpha sine of alpha plus C sine of alpha. But your sine of alpha, C sine of alpha, is equal to 0. So therefore, substitute the values. You have 99.5 times S, which is, so S is equal to A minus B. That is 3.5 minus 1, so that is 2.5. 2.5 cosine of 23 degrees 34 minutes, then sine of 23 degrees 34 minutes. Okay, so vertical distance is equal to 99.5 times 2.5 times cosine 23 degrees 34 minutes times sine 23 degrees 34 minutes. That is 91.16 meters. Okay. And then you have the inclined distance. For the inclined distance, you have the formula Ks cosine of alpha plus C. Okay? So where your C is equal to 0. So therefore, you have your K, that is 99.5 times 2.5, that is S, times cosine of 23 degrees 34 minutes. So your inclined distance. So you have 99.5 times 2.5 times cosine of 23 degrees 34 minutes. So that's 228.0 meters. Okay, so this is the answer. And then letter B, the difference in elevation between points B or A and B. So this one, difference in elevation. So to solve for the difference in elevation, you have this line, this one. So you have from the given illustration, you have your difference in elevation between A and B is equivalent to VD, then plus RR minus the height of instrument. Okay, so based from the given illustration, you have your height of the difference in elevation is equivalent to the VD plus the RR minus the height of instrument. Okay, so this is one line and then one line. So you solve for this, that is equal to this line minus this line. Okay, solve for the difference in elevation. Okay, so from the given, you have VD is 91.16 plus RR, that is 2.25, minus HI, that is 1.45. So difference in elevation at point A and B is 91.16 plus 2.25 minus 1.45. Okay, so that is 91.96 meters. Okay, so this is the answer. And then last, letter C, you have elevation of station B. Okay, so what is the elevation of B? So to solve for the elevation B, that is equivalent to elevation A minus the difference in elevation between A and B. So based on your illustration, or based on the illustration, you have the elevation of B is equivalent to elevation of A minus the difference in elevation between A and B. Okay, so substitute the values. You have elevation, which is 155.54 above mean sea level, minus 91.96. So the elevation of point B is equal to 155.54 minus 91.96. That is 63.58 meters. Okay, so this is the answer. So this is the answer for sample problem 1. Okay, so let's have sample problem 2. So for the problem, you have a transit with a Stadia interval factor of 100.8 was set on point C on the line between points A and B. So at the following Stadia readings were observed. You have the rod held at A, this is point A. So you have the readings, and then rod held at B, you have the readings. So if the Stadia constant C is equivalent to 0.381, determine the following. Letter A, the length of the line AB, then the difference in elevation between point A and point B, and if point C is at elevation 150 and the height of instrument is 1.58, compute the elevations at station A and B. Okay? So let's have the horizontal distance. So let's have the solution, class. So solution. A, length of line AB. So you have HD1. So length of line AB is equivalent to HD1 plus H plus HD2. Okay? So the formula for HD, you have this one. So HD is equivalent to Ks cosine squared of alpha plus C cosine alpha. Okay? So let's have HD1. So HD1 is equivalent to K, that is 100.8. And then S, so HD1 is rod held at A. So S is 1.33 minus 1.02, and then cosine squared of alpha, the angle is 15 degrees 35 minutes, plus C, given you have 0.381, and then cosine of alpha, which is 15 degrees 35 minutes. You have your HD1 equivalent to 100.8 times 1.33 minus 1.02 times cosine of 15 degrees 35 minutes, okay, plus 0.381 times cosine of 15 degrees 35 minutes. Okay? So that is equivalent to 29.36 meters. Okay, so this is HD1. And then HD2. So K is 100.8. Then S, that is 1.972 minus 1.736 cosine squared of 8 degrees 8 minutes plus 0.381 cosine of 8 degrees 8 minutes. So HD2, you have 100.8 times 1.972 minus 1.736 times cosine of 8 degrees 8 minutes, and then plus 0.381 times cosine of 8 degrees 8 minutes. So that is 23.06 69 meters. Okay, so to solve for the length of line AB, so LAB, that is HD1 plus HD2, so which is 29.36 plus 23.69. 29.36 plus 23.69. That is 53.05 meters. Okay, so this is the answer. So letter B. Letter B is difference in elevation between A and B. So you have the difference elevation between A and B. So this one, this elevation. Okay, so you have VD1 and VD2. Okay, so for this line, this is for the difference in elevation. So you have, from the illustration, you have the difference in elevation of line AB is equal to VD1 minus RR1 plus VD2 plus RR2. It is based in this illustration. So for this line, that is VD1 minus RR1, and then for this line, this is VD2 plus RR2. Okay, this is from the illustration. So if this is the difference in elevation, so this line is VD1 minus RR1, and for this line, this is VD2 plus RR2. Okay, so you need to solve for the vertical distance 1 and the vertical distance 2. Okay, so to solve, you have the formula for BD, VD. So the formula you have here, VD is equal to KS cosine of alpha sine of alpha plus C sine of alpha. Okay, so VD1 is equivalent to K, that is 100.8, and then S is 1.33 minus 1.02, then cosine of 15 degrees 35 minutes, sine of 15 degrees 35 minutes plus 0.381 sine of 15 degrees 35 minutes. So you have VD1. And then for VD2, that is 100.8 times 1.972 minus 1.736, and then cosine of 8 degrees 8 minutes, sine of 8 degrees 8 minutes, then plus 0.381 sine of 8 degrees 8 minutes. You have VD2. So let's calculate. You have 100.8 times 1.33 minus 1.02 times cosine of 15 degrees 35 minutes times sine of 15 degrees 35 minutes, then plus 0.381 sine of 15 degrees 35 minutes. Okay, so you have VD1 8.19 meters. Okay, and then for VD2, so VD2 is 100.8 times 1.972 minus 1.736 times cosine of 8 degrees 8 minutes times sine of 8 degrees 8 minutes, then plus 0.381 times sine of 8 degrees 8 minutes. So you have the vertical distance of 3.39. Okay, so let's solve for the difference in elevation. So the difference in elevation of line AB is equivalent to VD1, which is 8.19, minus R1, how much is our R1? So for R1, that is horizontal crosshair reading, or that is C. So you have here C is 1 for rod held at A, that is 1.175, 1.175, and then plus VD2, that is 3.39, then plus R2, that is 1.854, 1.854. So difference in elevation of point A and B, so that is 8.19 minus 1.175, then plus 3.39 plus 1.854. So that is 12.259 meters. And this is the answer. Then letter C. Okay, we don't have enough space. For letter C, you have to solve for the elevation of A and elevation of C, where the height of instrument of point C, the elevation of A and elevation of station B, where the height of instrument at point C is 1.58. Okay? So C, you have elevation C, that is 150, and then HI is 1.58 meters. to solve for the elevation at A, that is, so elevation at A, that is based from the illustration, to solve for the elevation at A from point C, or from elevation at C, that is the height of instrument, and for this line, this is VD minus RR. Okay? So elevation at A is equal to elevation C plus HI plus VD 1 minus RR 1. Okay? So you have the elevation C is 150 meters plus HI 1.58 meters. Then plus VD1 is 8.19, and then RR1 is 1.175. So 8.91 minus 1.175. So elevation A is equal to, so 150, so that is 151.58 minus 8.91 minus 1.175. That is, I know, plus, that is plus, so that is 159.315 meters. Okay, so this is the answer for elevation A. And then for elevation B, from the illustration, so to solve for the elevation at B, solve for this elevation, this is just the elevation at C plus the height of instrument minus VD minus R2, RR2. Okay? So you have here the elevation of C plus the height of instrument minus the VD2 plus RR2. Okay? RR2. So therefore, that is 150 plus 1.58, then minus, you have the VD2. VD2 is 3.39, and then the RR2 is 1.854. 3.39 plus 1.854. So elevation B is equal to 151.58 minus 3.39 plus 1.854. That is 146.336 meters. So this is the answer for elevation at B. Okay, so that's the answer to problem 2. Thank you. If you have problems or if you have concerns or questions, message me in our FB